Hey everybody, how are we doing? How's everyone doing today? We're here for some office hours, and there've already been some questions, but post your questions. Let's see if anyone has some questions right here. I already see one that was asked earlier in our place to ask questions. So hop over there, ask some questions. Let me scroll back up to it. For the next office hours, could you go over? I think I can copy the question. Let's put it right here. It's a really good question. Let's see. Let's put the question right here. Ah, there we go. And then let's move this. There we go. For the next office hours, could you go over? Drop this down right here, make it nice and easy to see. For the next office hours, could you go over when a number could be categorical versus when it is quantitative in regards to how the question is asked? So if you remember, this is a Stat 201 question right here. So let's put some little Stat 201 notes on this. Stat 201, I can't type today. Stat 201, we have right here, a variable is either categorical, quantitative, or identifier. And for this, I'm going to open up some Stat 201 stuff in the background right here. We've already got some quantitative data in that we were working with earlier. So here is jump. And jump is just a way of working with data. That's all jump is. So we can go here and we can put cars, like how many cars are in a parking lot. And then we could do maybe a store. We could go here to store. Now, the store would be something like Target, Walmart, different stores right here, Walmart, Kroger. Apparently, there's no cars in these parking lots. And what else? GameStop. Got to be GameStop. GameStop is probably not existing anymore. It's GameStop, GameSpot. GameSpot's the magazine. That's what I was thinking of. So we have here the blue and the red. The blue represents its quantitative, which changes the way we do different statistics on this. We can make histograms of this. We can make stem and leaves of this. We can make dot plots of this. This is a review from our last class. So you can see here distributions. And when we do it right here, we get a histogram. And that is a univariate display of quantitative data. So we've got the histogram in the background now. But the big question is that kind of started this all off is when is a number not really a number? What about if we put night versus day right here? And people might do this. They might do night 0 and day, I can't spell. I can never spell. Day as 1 right there. So someone might do this, and this is more like an indicator here. So someone might say that this parking lot was observed during night, and day. Now, if you notice, it is registering it as quantitative, but what I would do here is I'd go and I'd change this to nominal. And if you notice, that is a categorical variable. And what's really great right here is we actually have some 320, 474 concepts in here. We don't talk much about nominal and ordinal in Stat 201, but when you click this, you get the option for nominal and ordinal. Now, ordinal means it has an order to it. Like, let's try this. You ready? Let's change this completely to, I'm trying to think of a variable. Let's hear a little static. Static is bad. Hopefully it's just through my headphones. So let's think of a variable that would be ordinal that we could collect on this. Like maybe, that's where I need the chat to help me out. I'm like, oh no, I have to think of it now. Let's go to distance from center of town. So this will be like distance from house. This is the distance from our house these stores are. So we're recording data on like how many cars were in the parking lot in this store. What was the store name? What was it recorded at day or night? And this is the distance from our house. So let's do close, far, very far, and we'll repeat far. Now, if you notice, we have close, far, and very far. So this is an ordinal categorical variable. So this is still categorical, but I'm going to go here and select ordinal. And this is maybe something you haven't seen before. It makes the little green bar right here. I'll show you the green bar right there. That green bar means it's an ordinal categorical variable. Ordinal means it actually has orders to the levels instead of just being like different groups. The groups have an order to it. One of my favorite examples is stake preference. It doesn't work with this example because you can't do stake preference of like stores. But stake preference goes from rare to well done. Then there are things that don't have an order to it, like vegetarian, and I guess that's really the only one. But if you were to say like I don't eat steak, then that wouldn't be in the order of rare to well done. But if we were to say steak temperature, then steaks have to be cooked to a certain kind of ordering of a temperature. So steak temperature could be considered an ordinal categorical variable. So the big thing we need to know from this is we have categorical variables and we have quantitative variables. So categorical, all three of these are, and this is the trick here where unfortunately, sometimes we see numbers that aren't really numbers because day and night don't have a difference of 1. There's no difference right there. Let me see if people are posting questions. Feel free to post some questions. Who has questions? I might talk more about 32474 now. And so people can check back these. I'm trying to think what big things people will be encountering right now. I do have the homework open for it, don't I? Homework. Is it assignment? There we go. There's the BAS 320 assignment for this semester. Let's talk about some stuff right here. There's so much to cover tomorrow. And today. Today, if you haven't had class today, today's going to be a big class, tomorrow or today. So let's go in here. Let's see. Post your questions if you have them, and I'll answer through all questions. So we have a data set right here. Let's talk about number 4 for a moment. Consider various columns of alumni. Write all of the code to answer the following questions. Now, what I like to do, this is a big hint. I need to put a mark in here to be like we're talking about 320 now. Is when we work with code, I like to code right next to it. So if you're watching this right now, here's a big trick. We're going to go here to insert, and we're going to insert an R chunk. When we insert an R chunk, it'll actually let us code right here. Now, this is the difference between where we just write out the Word document portions and where we write out the coding portions. So this part right here, that's a slightly different color with the arrow where we can play the chunks. This just plays the chunk. Like if I put 2 plus 2 right here, it'll run the code when I hit play. I can also put in more code, like 3 plus 3, amazing code today. We'll put this in and it'll run all the code right there. I'm going to clear this out and just run both those codes, and it plays the chunk of the code. So we should know the difference between here's where we can write whatever we want. We just write whatever we want because that's just like a Word document. And then this is where we put code. This is inside of RMD files. And RMD file stands for R Markdown File. That is where we can do code and do a Word document. So be dropping those questions if you have them in the live stream chat. So you should be able to see that over on our thing. But ask a question, ask me to work a certain problem, and we will work those problems. That's how we'll do office hours. It looks like you ask the question, I will work the problems. And I'll drink Starbucks. Not sponsored by Starbucks. Wish we were. Starbucks, send us stuff. No, don't send us. We can't do that. So with this right here, those Starbucks cold brews are pretty good. So I'll make sure I don't. Yeah. Okay. So what do we got going on right here? We've got the alumni data set. And is the alumni data set in red class? Where's the alumni data set? Do we have it? Oh, nope. We got to load it up. I think the alumni data set is loaded in with the data way earlier on. Let me show you where to get the alumni data set. This is where people are going to run into a problem. And let me go to load. Am I losing? There we go. I was like, I'm not losing my mind, am I? No, I'm not. So on line 38 right now, we have that we're going to load in this R data. And just to show you what happens right here, this is going to load in a bunch of things into the environment. So what is an R.data? This is a good thing to know. What is an R.data or .r data? .r data is an environment. An environment can have in it functions, it can have in it data frames, it can have in it values, but an environment is basically the brain of R. So you're loading in a new brain. So what's going to be in this brain? Well, let's find out. Whoa. So we've got here a few things. We've got here the print questions for question number 2. So we loaded in a function, and we loaded in the alumni data set. So what is a .r data file? It's an environment. And the environment is basically a brain. It knows certain things. You can clear your environment with this dustpan. There's a lot of dustpans. You can clear this right here, and you can clear this, and this will clear the environment of everything it knows, and then we can just reload up the brain of R. And that's kind of, if you want to clear out what it knows and have it only work with certain things, you can just start a fresh environment and not have things in the background. We're going to put our student ID right here. Mine's going to be 7 as my student ID. No, enter in your full student ID, obviously. But we'll put our student ID right there. This will tell us my student ID is 7. Nice little thing, printing what we put right there. And that's got that. Let's go back down to those question number 4s, I think it was. They seemed like fun. And it has right here, I don't think we need this R chunk now. Go away, R chunk. Let's do a few of these. What is the grand total of the amount of money that has been donated to UT? The sum of all the values that are in lifetime gift to UT. So that's what LTG to UT means, is lifetime gift to UT. So there's a donor data set, and we're going to look right here. And I'm going to do it right here. So hopefully, I don't know, if I see your assignment and you're doing the work right here, I know you kind of followed along and you did the work, like by watching the video, which is a great way to do it. And we're going to go here to R, and we inserted an R chunk. Take a look at the difference. I can't write code right here. I think they changed it so it sends it down. Don't write code right there. It won't evaluate when you knit it. It'll show 2 plus 2, but the newer version of RStudio and everything lets you actually send that to the console. I'm going to go right here and insert an R chunk. I went there and I clicked insert R chunk. I like doing my code right below the question. It's easier for me to see and double check my work. So what are we going to do? We need to learn some few major things. This is 320 I'm talking about right now, so these are new things to you. Alumni is a data frame. A data frame is basically an Excel spreadsheet. So with this Excel spreadsheet right here, basically just, Excel spreadsheet. Rows, columns. I mean, I can go into more detail on what an Excel spreadsheet is, but like this is a person right here. There's a zip code. There's area code. We've no mailing address. We've got all these different things right here. But there is the Excel kind of data sheet with rows and columns. So what do? We go to alumni. We could view the whole thing, but now I'm going to do a $sign. So this is the big thing. Do you remember how inside of here we saw different kind of vectors? Inside of here, we have all the different vectors we can be using. So let's take a look. We've got gender code, zip code, area code, email address, job title, city employed, all these things right here, different things. So you can type ALU and you get alumni. It auto completes. Then you can hit enter and do $sign. And with the $sign here, you can get all the different variables. Let's type LTG, and guess what? We can see 2UT. We hit enter again, and now we can take a look at the vector. These are all dollar amounts that have been donated over the lifetime. Like someone donated 28,000, 28,000, 20,000. These are all the lifetime gifts right behind me. And one person asked a really great question earlier today. They said, what does this 904 mean? This is person 904 donated $0. Person 925 donated $28,525. If you change the size of the screen, it'll change where those positions are at. So this is person 1000. These are kind of markers for you to see kind of this is this person, this is this person, this is this person, and to see their position. Imagine if you put everybody in a line, you're like, okay, I need to talk to person 500. You say, okay, person 500 donated. Okay, so this is not 498. This is the first person right here. It tells us this is 499, and then person 500 donated $25. We can even confirm this. Here's another thing we should know. Let's see, I think our code is right here. Person 500, how much did I say they donated? $25. So that confirms that we found person 500. Now, this is not the question, but it's showing you some things about this that you should understand. This vector I'm viewing right here of the lifetime gift is the exact same thing as us going right here. Sorry, there's noises outside. And looking at just the vector, if this is lifetime gift right here, and scrolling down the vector. Got the window open, and so hopefully I'll close it here soon. But with this right here, we should see this is a vector of lifetime gifts, and we want to know how much money was spent in total, or how much money was donated in total. Go before it, type sum, and then it's going to take the sum of this right here. Boom. We've done it. I think it might say print to the screen, but don't worry. Well, it doesn't say print, but this is how we print to the screen. When you knit your document, this will show up. That's got it. Let's see if there's more questions. Remember, put questions. Oh, someone's typing a question. Awesome. I see there's a question being typed. You put your questions in the live stream. We answer them here live. This is like live. You put your questions. You can even put them when we're not live, and I'll answer them next time we're live. What percentage of a number between 0 and 1 of alumni have not donated? And there's 2 ways to do this. So once again, I'm going to add in. I'm going to do this question here, then look over at the questions people have put in for us to answer today. So we have here, what percent have not donated? So this is where we have to know how to do a logical check. We want to see if someone has donated or has not donated. So let's go to the alumni data frame. That calls it. We hit enter. I'm going to do a $sign to get the variables inside of it. So this lets us look at the variables. Let's look at, is it donate? What is it? The variable is, oh, we don't have if they've donated or not. We have to go to how much they've donated. So lifetime gift to UT. So someone either donates or not donates. I wish I could ask the chat right now. How much does someone donate if they've never donated? If they've never donated, then they would have donated $0. And we could check this out. Okay, this person right here has not donated. This person right here has not donated. This person here has donated. This is where we have to know how to do a logical check. And let's do one quick revision of this. I'm going to look at the question here. I might want to say, let's say amount. I'm going to store this, delete this from your assignment. Don't put this in there. I see sometimes people put the extra things I put. You don't need to put these things. I'm just explaining the concept. Amount equals 0. Let's look at the two differences right here. This code right here stores 0 into amount, technically capital amount. And you could use an equals. I don't like using equals, but it's still the same thing. It'll store 0 into amount. It's the same thing. This code right here checks to see if amount is equal to 0. So notice how this code returns true because it's checking to see if the amount is equal to 0. So what if we did this on a vector now? Instead of just checking one amount, because this amount is 0, I stored it as 0, and then we were to take all of the amounts like we do here. All we have to do is say which of these amounts are equal to 0. We don't need that code. That was just explaining the concept. So now we can see where people donated 0. And it wants to know what percent. Well, we could have the hard task here of adding up all the trues, because that's people who did not donate anything. But how about this? Since trues and falses are 1s and 0s, and I can prove that to you by going true plus true. And if you're seeing this, you should know true plus 2 equals 2. True plus true plus true equals 3. But what if we did true plus false? That would still equal 3 because it's adding up the trues. What if we do the sum of this? That would equal to 3. But what if we do the mean of this? That equals 2. Oh, I know why. Haha. Have to change our code a little bit here. And I might have to explain. And then we got a question I see that was appearing. Awesome. So the sum of this is still 3, but the mean of this is now 75%, meaning that 75% of this vector is true. Because what does the mean do? It treats these as 1s and 0s. So these might as well just be 1s and 0s. And it takes the mean of this vector. It's 1, 1, 1, 0. And that would tell you that 75% of the time it's 1 or true, because trues and falses are just 1s and 0s. So if you're looking at this right here, just remember trues and falses are treated in the background as 1s and 0s. So what could I do? This is basically the answer right here. Maybe we'll see this in someone's assignment. Hashtag that out. That's a good reminder. Because this vector right here is just trues and falses. I'm hitting Shift 9 to put a parentheses around it. That's my quick check right there. And then I go mean right here. And there's the answer. That's the amount of people who have not donated because they've donated 0. So I asked, who has donated 0? And I said, what percent of people have donated 0? That's got it right there. Let's see. I think a question was appearing in the live stream chat. So can we work in the datasheet itself, or is it just something you look at? That's a great question right there. So, and tell me if this answers it for you. And so feel free to put a reply. One of my things that I often do, this is how I like to work, is down here, it's got all the different parts. I don't like to code so far away from where I can't see the question, because then I can't see if I get it wrong. Now, please note, if you saw what just happened here, I want to point this out because I don't want anyone to make this mistake and then their document has problems. Look at what happens when I delete this. When I delete this, everything goes gray down below. That's because that's turning into code and all of a sudden errors exist. You have to actually delete out the whole chunk and now you're fine. You can code down there and you should be coding in the document. So really big thing to point out is make sure you're coding in the document itself. I like to do my answers in line and which question are you working on and which one do you want to see. So we got some people watching right now. Which thing are you thinking about? And I might do another one here while we see. Let's do C. See how much time I have and how much I can do. So print to the screen the values of gender code in these rows. That gives us a really good topic to talk about right here. So let's talk about positions in vectors. So when we look at gender code right here, gender code is a vector inside of alumni, and you see it right there. So what do I mean by a vector? It's basically just like a long column of data. A vector is one-dimensional. So vectors are one-dimensional. Data frames are two-dimensional. So a data frame has rows and columns. A vector just has element positions. A lot of times you might just say element position because it's just the element of this. Element works also like element number 200 or position number 200 in the vector. But it's one-dimensional. It just goes up and down. So with this right here, we need to go to the gender code vector and print to the things in rows 200, 201, 320. It's classes. Yep. Remember the phrase print to screen just means ensuring that the command left arrow in the results. Perfect. Okay. So let's do this right here. Let's go to alumni. We're going to use autocomplete again. And then how do we get inside of a data frame? How do we get inside of it? We hit $sign. $sign connects data frames to vectors. And what do? We're just going to hit enter here. We don't need to type it. We'll get it correct with enter. And now here's the tricky part. Here's the tough part. People make a mistake right here because they start typing in all of the positions. This is the most common mistake. Brian is doing it incorrectly. I need like a warning on the screen, like I should make that like Brian is purposely doing something wrong. I could make that graphic. So this is incorrect because what I've done right here is I've taken a multi-dimensional thing. I've said go to position, or I should say vector space 1, or kind of dimension 1 element 201, dimension 2 element 320, dimension 3. It's saying it's a 5-dimensional object. This is bad. This is wrong. This is not going to work as code. So what do we have to do? This will make it simpler to see. Here are the positions we are interested in. We want these positions, and we are going to call those positions. That makes it a little bit easier to see right here. Because how many dimensions is a vector? What are the dimensions of this vector? If you look at it, it's just one dimension. You might be saying to me, Brian, it looks like it's 2 because it looks like it's a square. No, it's just a vector that wraps around. Because if we look at it, especially this way, you can see gender code is just a column. A column just has positions like this right here. So we can see that we are just calling the positions in 201, 320, 474. We can even take a look to make sure we have this right. Let's go to 201. Oh my gosh, this is the craziest, longest data set ever. So 201, got to scroll this way. 201 is, we'll just check 201, is male right there. And so 201, when we see the position right there, should be male. And boom, there we go, we got it. There is position 201. And with this right here, we can see that we get all of those positions. And this is a one-dimensional object. But there's another way. There's always another way. Check this out. This is another way of doing it. What I've done here is I've solved the answer the same way, but showing it a different way, which it's the more ways you know how to code something, it's like speaking a foreign language. If you know how to say something 3 ways, you have more options and it makes more sense. So in this instance, alumni is a 2-dimensional object. Let's put that right here. Working with a 2-dimensional data frame. And this is working with a 1-dimensional vector. And so I think where people get confused is there's ways of writing, especially when you first see it, because I could just take this and put this right here. These codes all do the same thing. Watch as the output for all 3 codes is the exact same answer. So let's look at all 3 outputs. And you only need one of these. It's just showing you that they're all 3 the same. Same, same, same. But this right here shows you all the things we're taking the positions of. And so we're creating this positions vector, probably a better way of doing it. So I'm going to remove this line completely and just show you that we're just going to take the positions in the vector. Now we could go to the data frame, get the positions, and go to that column. That's another way, because now it's saying take the positions from this column in the alumni data frame. The more you can read your code as a sentence, the better and easier it is to understand. So the more you can read it just as a sentence. Let's see if there's more questions. Oh, yes, we have a TA online right now, so check it out. Oh, I see some 320 questions. Perfect. Jessica's totally ready to take questions, and I am still answering things here. Let's do a few more questions here. And let me do this. And there we go. 320 roll. Let's see if there's more questions. Let's do a few more on here. So if you do have questions, remember you can post them. You can email me them. Say, hey, Brian, work these during office hours. Best if you put them online for us to see, and we will work those questions. Let's see here. Print to the screen the last 6 entries of area code. So when it comes to the last 6 entries of area code, we need to understand what function we need to use right here. So the last 6 entries of area code are going to be the tail function. So what does tail do? Well, let's make a vector right here. This explains how to use tail. I'm saving a vector, and C just is basically like gluing things together. Like watch as I go like 4, 3, 2, 1, 1, 1, 1, 1, 1, 8. So this is going to glue those numbers together in a vector. So I've glued all those numbers together into a vector that we can then use. With this vector right here, let's run the tail function on it. When we run the tail function on this, we're going to see that we get the last so many elements of the vector. Now, this is not the answer to our question yet, but it explains how the tail function works. The tail function merely returns to you the last certain amount of elements that you're looking for. So tail of the vector returns the last 6 elements by default. But what if we want the last 3 elements? It doesn't say that, but what if we did? There we go. A second argument here returns how many elements you want the last of for some sort of vector or data frame it can work on too. But we want the last 3 elements of the vector or the vector. It's called vector. We could call it Nintendo. Why not Nintendo? It's a cereal. You get what I'm saying? Nintendo. So there are the last 3 elements, and I've just stored a vector named Nintendo and taken the last 3 elements right there. What if we do head, though? Head and tail. So head is the first 3 elements. So this is the 2 important functions to know right here, the head function and the tail function. Head returns to you the first so many elements of a vector or a data frame. Tail returns to you the last so many elements. So you could pick even like, what is the first element? And it will say 4. You should know that. What if we do tail and it'll say 8? What if we do tail 2? Well, then it's going to do 1, 8. There we go. But there's, I don't want to make it too confusing. I'm going to mark this in the video as like explaining the head and tail, how it works. So hopefully, you know, this helps understand what we're using here with the tail function. If we say the last 6 entries of something, we want to go here and take the last 6 entries of area code. So we're going to go to the alumni data frame. We use the autocomplete. Then we do the $, and then we go to area code. And now we're going to take the last 6 elements. We're going to go to tail, and you could enter in comma 6, but the reason we don't have to do that is because it's 6 by default. Just by default, there are 6 things that we have right here. So that's got it. Let's take a look. Let me see if there's more questions right here. I don't think there's more questions yet, but if people have questions, be posting those questions. We already had one today, and hopefully that helped out with the question right there. Let's see. What is the largest value of area code? Well, I need a drink before this. Oh. Okay, there's going to be an issue with this one. So, this is where we run into problems, is because sometimes certain functions don't work the way you'd expect them to. So this is going over, I should hit the thing to like mark the video. I could. Let me try that. Let me try something on the fly right here. Is that the button? Which button? Oh, that's the wrong button. Insert stream marker. Okay, let's see what happens. Stream marker added. Okay, so what is the largest value of area code? Well, this is going to be the max function. And you'd think, okay, Brian, I'm good. I got this. I've been following along. Whoa, we got some help stuff. That might be very important for us in a moment right here. But we are going to get the largest value of area code. So we need to go here and take the alumni data frame. We're going to hit enter to let autocomplete help us out. Then we're going to do $, and we're going to go to area code, and we're done, aren't we? Wait a minute here. All of a sudden now we don't have an answer. And why don't we have an answer? We don't have an answer because we have NAs. So let's look at this. If we were to have a vector, we're just creating a vector. This is just a vector we're creating. And we were to have 4, 5, 9, 9, 9. And if we were to do max of this vector right here, we get 999. But what if we had a value NA? The value of NA means nothingness. So what is this NA? And you can tell it's a special character because it changes colors. If you notice right here, when it's N and then A, it changes colors right there. And that means it's a special character, which means like nothing. It's nothingness. It's missingness. So with this NA right here, it creates a nothingness when we ask for the maximum. But what if we put in an additional argument? Here's a big thing you should know. Put this in your notes if you're watching this right now. Arguments inside of functions are separated by commas. So we put a comma right here, and then we do na dot, and there it is. This is an argument right here indicating whether or not we remove the NAs. So this is the first argument. I want the max of this vector, and I want it to remove NAs. If you notice, when I type capital T, that changes colors, meaning it's a special character. When I type capital TRUE, it also changes colors, and this works. And if you're following along, this is where you're like, wait a minute, this is crazy. I don't have to put true here. I can actually put 1, because 1 is equal to true, and it also works. If I put 0, 0 is equal to false. So you can put true or false. Maybe it makes more sense, like just looking at it, to put true. But this right here is how we can get the max when there are NAs in the vector. If there are NAs, you have to remove them. So we're going to just take this. Let's just copy it and paste it. And one big thing I want to point out is that this na.remove has to be used for quite a few functions. Take a look at this, and don't include these in your assignment. Don't include these. If we go here to sum of alumni and area code, there's NAs, and you see it says NA, so we have to do na.remove on that. I think the mean also, yeah, mean, median, all of these you have to do na remove equals true. I think it just wants to alert you to the missing data, hence why it doesn't give you the answer until you do na remove true. So you do not get the answer to these until you do na remove equals true, and that's how we make sure that we get the information. Let's see if people posted some questions. Remember, post your questions in the live stream chat that we have made the channel for, and check that out. So that is how to deal with NAs and do the max if you need. Which row contains the maximum value? Oh, there's such a quick fix to this one. Let's go into some pretty big detail on this one. There's such an easy fix for it, though. The easiest fix we can have, let me see one thing real quick. I am wondering about one thing in the background. Nope. Interesting. And so with this right here, which row contains the maximum value of lifetime gift to UT? So when we go right here, we want to find which row contains the maximum value of lifetime gift to UT. So what we would do right here is we can find out the maximum value. Well, we did that right here, but we can change it so that we just go here to lifetime gift to UT. There it is. Now we know what the maximum value is. That is the maximum value of the lifetime gift to UT. How about we take this and we call this like max donation. There we go. We've now stored the maximum donation. That's there's 61 cents. Awesome. I mean, this is ridiculous. That's very generous. So I was like 61 cents. I'll help out there. I'll round that up. That's the help I can do. I mean, I do more than that, but I hope. So with this right here, with the maximum donation, here's what we need to do. We need to find this individual. We need to find and actually see which row this is. So what we can do is we can go to alumni, and we could actually figure out, who's donated $0. Let's do a different type of question. So let's go lifetime gift to UT, and let's go equals 0. Now, if you notice right here, these are the people who have donated $0. This person donated 0. This person in row 961 donated 0. These are all the people who donated 0. So we asked, here's all the lifetime gifts to UT. And then we said, well, which ones are equal to 0? And this is logical equals. Remember, equals is logical equals. And now we just have one more step. Here's the one where people get lost on. Since I know these are the people who donated 0, I can find out what positions they're in. As in, where do they exist in the element space? And there's their positions. Putting a which around a logical vector gives you the positions of the true. To show how that works, let's do a simple example here. And let's make another vector. I always call it vector just because it's easy to create, and just call it that. I'm going to go true, true, false, true. And now what if I go around this and I say which of vector? Take a moment and think about what this will say when I do which of true, true, false, true. And here's the way to remember. Which returns the position of the condition, or which returns the positions that meet the conditions. That's it. Which returns the positions that meet the conditions. So wherever the trues are at, that's where we will see the positions returned for. So let's take a look at this right here. what will we get? We will get 1, 2, 4, and we get 1, 2, 4 because the things that meet the conditions right here are the trues. Now, I didn't really write a condition, but think about this. This code right here returns trues and falses. So when I put a which around it, it tells me where the trues are at. So all of these numbers you see right here are just where the trues were at. So it's saying like, oh, okay, let's see. Here's what people donated. There's all their donation amounts. And then I want to know where people donated $0. Well, let's take a look. The people who donated $0 are in these positions, true, 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 all those positions. And then what are the numbers of those positions? And there's the numbers of those positions. So that does it. And we're just one step away now because we don't want the people who donated $0. We want the person who donated the max donation. And that's it right there. There's a really simple way, though. There's such a simple way. And the simple way is which.max. Which.max gets you the position of the max. I know you're like, Brian, why? If it's that easy, why didn't you just do that? Sometimes we like to do the harder way. And there's the same answer right there. Take a quick drink right here. Be posting your questions if you have it. Just working through part of number 4 for BAS 320. Help out and give some people some advice with this right here. And I should be posting another. Oh, I see a 474. Is there? I don't think there is. I don't think there is for that, but we do have this right here. So be post your questions, and we've got the general chat and everything like that. So I see the question. Not that I know of, but you can post questions here and work together. Yeah. I do not know. Let's continue on. Let's do, probably finish number 4 today. How many rows have lifetime gifts to UT greater than $500,000 and values of area code that is equal to this? Ooh, we have 2 conditions right here. 2 conditions. So we want rows where people are in the 865 area code and they've donated more than $500,000. That's pretty awesome. So let's go here and insert another R chunk. This just lets us code in this area. So I just like coding it next to the question so we can see the question as we work it. You can do the same and then just delete out extra things. You want your documents to look really great when you turn them in. So we have here alumni. And let's go lifetime gift to UT. And we want that they've donated more than $500,000. Now there's a quick way to write 500,000. I think I know how to do it. I'm so between. Let me just think. E to the 1. So it would it not be? I'm going to make a mistake. Here, watch this. Wait, watch this. So I'm pretty sure it's going to be, let's see here. I always make a mistake. Oh, it is 5. I knew it. There we go. It is. There we go. And that's 500,000. It is the amount of zeros. I knew that. I'm much better with the negative scientific notation. Like that's e to the negative 4. So unless my brain's not working today, sometimes brain just fails you. So it is going to be, and you could just write 500,000. Is it greater than? Yep, it's not greater than or equal to. There we go. There's the 500,000 right there. And we could write this. We could get all these right here. And it's the same thing as writing this code right here. If we do 5 plus e to the 5. Oh, just totally making mistakes right there. I can't think today. So my brain is just, there we go. E plus, damn. There we go. Just reversing things. Small mistakes, big errors in code. That's the way it goes. 5e plus 5, and that is the amount of zeros you see right here. That is the same thing. And so let's make it look like this, a little easier to read, especially until you get into big numbers. You don't really need scientific notation. But how many rows have people who have this and this? Now, this is where we get into logical conditions. I've got a video on logicals, but let's go over a little bit here. When you do logicals, you have ands and ors we're starting out with. So what if we do true and true? Where's my and sign? I have never been able to find it. This will report true. What if we do a few more right here? True and false, 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 and false. So the only one that will report true right here will be this first one. True, true, false, excuse me, false, false. As I said, the only one to report true here is this first one. But watch this. I was really thinking about the next example. Now let's do an or, which is a pipe like that. It's right above enter. If you're looking for where the or is at, it's right above enter. So this is going to change slightly how it works. True or true is true. True or false is true. False or true is true. And false or false is false. So if you notice right here, when you have true, everything connected by a true must be true for it to return true. If there's one false, it'll be false. When you have ors, you only need one true. So a really good test question could be something like, we take this line of code right here and we say, what will, let's do this. And then what will this line of code return right here? So this line of code is false or true or false or false or false or false. This will return true because there is one true and you only need one true with ors. It's like you can have this or this or this or this, and as long as there's a true, you get the true. But when you have and, let's look at how the and works in a bigger example. If everything has to be true with the ands for it to return a true. So if you are using the ands, you must have all trues connecting it for it to return a true. So if you look at this code right here, we have one false, and instantaneously, because there's one false, we get false. So when you connect things with ands, you have to have all trues for them to be true. When you connect things with ors, as long as there's one true, you will get a true. So it's kind of like the opposite of each other. Trues, they have to be all true for you to get a true. Ors, you only need one true for there to be a true. Hopefully that makes sense to everybody right there. And this is kind of showing the small version of it. This is true and true, true. And since there's a false, all of these will be false. If you look down at the bottom where it's evaluating. And then we have where we have an or, and as long as there's one true, we get a true, but here's there's not true, so we don't get the true. So when you think about this code right here that we're about to write, we're going to ask that these people meet these two conditions, that they have donated more than $100,000, and also that these people and alumni have an area code that is equal to logical equals to 865. So these are the people who have donated more than $500,000. These are the people who live in the 865 area code. These are the people who meet both conditions right here. So these are the people who meet both conditions, and since trues and falses are ones and zeros, we can sum them up. So now that we've summed them up, hopefully someone saw what went wrong here. See, we always run our code. We always check our code. I wish I could ask people in class, like, what went wrong? I know what went wrong, and the answer to what went wrong is this right here. So sum also has to have NAs removed because there's NAs in this vector. So since there's NAs, we have to add an additional argument. And we have to do na.remove equals true, and now we've done it. So you can always make little mistakes right here. I wasn't even thinking, oh wait, there might be NAs, but you always run your code, and then you have to know what the error is. And I wish that was more specific. Like I wish it put out a comment saying like, if you want, remove NAs. But then people might be like, I know about that, and I knew it when I saw it immediately. Let me see if there's more questions. We got enough time to take questions or do maybe one or two more problems. People advancing in levels. 201 might have a question. Does anyone know where the video for visualization 2 help is? Or is it just one for the first one? Yes, let me post that for the person right there asking about it. We'll post that. Let's see here. We're going to post the video for the person asking for the visualization 2 help. I need to add it to the playlist. There we go. Could do that in the background here while we're... And then I could also mention... Yep. Awesome. Good deal. Let's see. And what I need to do is I need to put this into the playlist. Let's see. People are using the visualization 2 video. And let me add it to the playlist here in the background. Playlist, visualization assignments, done. And now we've got it. Good deal. That's got that. Let's see if there's any additional questions. What fraction of alumni have values of lifetime gift between these numbers? So we want now to do an or, it looks like right here. We want to do above a certain number, below a certain number. Let's check it out. And let's go to insert R. What fraction of a number of alumni have values in lifetime gift to UT that are between this and alumni, $, and we want lifetime gift to UT. And we want that it is greater than 50, including these amounts. So we have to do greater than or equal to 50. So these are the people who have an amount greater than or equal to that number, and less than 500. So now that I'm saying it needs to be greater than this amount and less than this amount, we need to make sure that we do the and symbol here. And now we're just going to copy paste this. I could have written it out. And we're going to go less than or equal to 500. So this doesn't give the answer yet, but now think about this. These are all trues and falses, and trues and falses are ones and zeros inside of R. And since they're ones and zeros, we can just sum them up. Now, hopefully we don't hit another... we don't. We got it worked out. There was no NAs there, so we are good. But this has done it. We figured out how many. Let's see. I think we can do it. We only got 2 more. We'll finish right on time here. Great stuff. If you have questions, email me or post your questions. How many alumni's values of lifetime gifts are multiple of 1,000? Ooh, this is a tough one right here. Generate the sequence that starts at 1,000 and ends at this, and that goes up in increments of this. So let's do this in parts. The second part seems to be the easier part. So we want to go here and create a sequence. And with this sequence, we're going to start. So from equals to 1,000. And let's see here. So starts at 1,000 and ends at this. So 2 equals this. And then by equals 1,000. So from 1,000 to this, by this. So this is the toughest question maybe on here, and we got everything running on this. But what do we do now? We want the people who have lifetime gifts that are multiple of this. So in other words, somebody's lifetime gift is contained in this, as in it's a value of this. This is the hard part right here. We're going to see if somebody's lifetime gift to UT, this is probably one of the hardest ones, lifetime gift to UT is contained in %, this sequence we made right here. And that will return trues and falses, and I think it worked. There we go, some trues. And then we want to know how many. So if we want to know how many, what do? We do sum, and we might have NAs. We don't. So let's review what this does. I said it's contained in. Let's do some simple codes with it to practice. Is 5 contained in 5? This will return true, because that's asking, is the number 5 contained in 5? Well, yeah, 5 is 5, so it's contained in it. What about, is 5 contained in the vector 1, 2, 1, 4, 5? So you're asking, is 5 contained over here? So when you look at 5, does 5 exist over here, true or false? The answer is true. But is 2 contained over there on the right? Is 2 contained over here on the right? And the answer is false. So 2 is not contained over on the right. So think about this. What if we had a bigger thing here? If we had, is 1 and 3 contained on the right? This will return a true or false for the first element and a true or false for the second element. And so what we see right here is this should return true for 1 and then false for 3. It's saying, is 1 contained over there? True. Is 3 contained over there? False. And so we see true, false. But what if we have something much longer, like 1 through 10? Well, now, think about what we'll get here. It's going to ask, is 1 contained over here? True. Is 2 contained over here? False. Is 3 contained over here? False. Is 4 contained over here? True. 5 true. 6 false. 7 false. All the way over. And there we go. There's that. It's just checking each element here to see if it's contained over here. So think about this. We made a sequence of numbers. Here's the sequence of numbers we made, multiples of 1,000. And then we're asking, okay, we're going to check everyone's lifetime gift to UT, because that's what this is. It's all these different lifetime gifts to UT. And then we're going to see, is that value then contained over there on the right? And it's just checking to see, is this over here? Is this over here? And it does it for each element. So it says, it starts off with this first person here, all the way person number 1 right here. It says, is 0 over here? Is 130 over here? Is 60 over here? And it just checks each element to see if it's contained over on the right, and then returns trues and falses. Print to the screen the possible values, levels of degree campus. I think this has got it. This will be one of our last questions. I'll see if there's any more on our server right here. Looks like we're doing pretty well. But let's go over here and look at the last question. We need to print levels, and this one's nice and easy. A good way to finish today is we have levels, and let's take a look at levels right here. All we have to do to look at the levels of something is we're going to pull up in the data frame right here. We're going to go to this, and we're going to go to degree 1 campus. And with degree 1 campus right there, it'll show us all possible levels, and we've done it. Now, what are the levels? That actually brings us full circle back. That brings us full circle back right here to the first questions we were doing related to categorical variables. So this is a categorical variable behind my head right here. It's the different levels of the UT campuses. And so we have UT Chattanooga, UTK, UT Nashville, Martin, and HSC, UT Medical, HSC. I should know that one. Then we got blank. Blank is something we should probably fix in the data frame. But these are categorical levels because when we look right here, we should see degree campus 1 is a factor. So if you're reviewing from today, factors are categorical variables inside of R. And I think that's got it. We did all of question 4 right here, and we talked a lot about how to deal with different data. And I'm pretty sure we moved off some of the harder stuff at the end. Yes, we did. Does it still say to install mice? You won't need to. Yeah, you don't have to. So let me remove that. I'll re-upload this later if anyone's working on it yet. But that's got it. I will see everybody later. I'll see some people in class. I'll talk to you then. But good luck and email me if you have questions. Bye, everybody. Bye for now.